Now we're going to look at another situation of finding probability with a normal distribution. So we have the same example. We are looking at the lifetime of a specific brand of batteries that are normally distributed with a mean of 500 days and a standard deviation of 61 days. This example says find the probability that an individual battery lasts between 425 and 675 days. So we're being asked to find the probability. We're looking at an individual battery. Now we're looking for between, and we have two values, 425 and 675 days. So for this type of problem, we have to find two z-scores. I'm going to call the first z-score ZA, and that's going to be the first number. So 425 minus 500 divided by 61. And then ZB is going to be the second one, 675 minus 500 divided by 61. So two different z-scores. So 425 minus 500 is negative 75, divided by 61 is negative 1.2. It rounds up on a 9. I'm going to do 4 just so I don't have to round up on a 9. It's 1.2295. I didn't want to round the 5 up on the 9. So just going to keep an extra decimal on that one to make my life a little bit easier. And then 675 minus 500 is 175, divided by 61 is 2.869. A lot of these end in 9. All right, so that's our first step. I forgot to label it, but we found our z-scores. Our second step is to draw our bell curve and label both z-scores. So I always draw the middle because it's a good identifier. Go. All right, and then we have -1, -2, because our first z-score falls between -1 and -2. Wowza, that is not at all where I wanted that to go. That would be like halfway, maybe like right there? Sure. It is not an exact science. So that's ZA. And then ZB, 1, 2, 3, 2.86. That's going to be closer to 3. ZB. Step 3 is to shade and our keyword here is between, and we're going to shade between, everything between ZA and ZB. There we go. So now I'm looking at this and it looks maybe like 70, 80% shaded. It's a little hard to tell. But again, the shading is to kind of give you an idea of how much of your curve you've shaded, what it is that you're looking for, and it's actually going to be really helpful as I go to explain what we're going to do in Excel. So as a reminder, when we go to Excel, when I plug in what I want Excel to calculate for me, it's going to calculate everything to the left. So if I tell Excel, I want you to calculate this guy, 2.869. When it gives me the answer, it's going to give me everything less than 2.869. So it's going to give me the entire shaded region that I want, but it's also going to include this unshaded region that I don't want in my answer. So what I'm going to do is I'm going to take my ZA negative 1.2295. Everything less than ZA is that unshaded region that I did not want in my original answer. And I'm going to subtract off the probability of everything less than ZA. So I'm going to do this broken down so we can see it, and then I'm also going to do it all at once so you can see how you can do it all in one. So I still have the previous examples up here. So the first one is norm.s.dist 2.869. Oh, I already forgot. See, 869, comma, true. 0.9979. Okay, so that is the region in blue. So everything in blue less than 2.869, that probability is 0.9979. But again, that includes this region here. I don't want that region. So now I'm going to find this section up here in pink, which is going to be everything less than ZA. So let's go find that area. Equals norm.s.dist negative 1.2295, comma, true. 0.1094. So the area below ZA that I have shaded up here in pink is 0.1094. So if I take 0.9979 and I subtract 0.1094, the result will be the original area that I wanted, which I had in purple, between ZA and ZB. Make sure you do the bigger one first. Your answer should be between 0 and 1. It should not be negative. 8, 8, 8, 5. That is the probability that a battery lasts between 425 and 675 days. That's the area in purple between ZA and ZB. If you wanted to do this all at once in Excel, this was all step 4, you could do norm.s.dist 2.869, comma, true, minus norm.s.dist negative 1.2295, comma, true. It's the same thing I just did, but I'm just doing it all at once. So I'm going to show you that when I do it all at once, I get the same answer. It might be slightly different because I did round the probabilities before I subtracted them, but I think it'll be the same. So coming in here, norm.s.dist 2.869, comma, true. Close the parentheses, hit subtraction, norm.s.dist negative 1.2295, comma, true. So I have it typed out all in one line as opposed to the two separate lines. And then I hit enter. And I get 0.888499, which rounds to 0.8885. So it is the exact same answer. There's no issues with rounding. You can do this either way. You can do them separately and then subtract, or you can do it all at once and just get a single line answer, whichever one you're more comfortable with. But let me go back to this so that you can see the summary of what we did. There you have it. Calculating probability with a normal distribution between two values using Excel.